Good afternoon, sir. My name is Rishabh Sinha. I am from Kolkata, West Bengal, and currently I am doing a data science and artificial intelligence course at AlmaBetter. And this is my second project on module 2, that is numerical programming in Python. So we were given 5 or 6 projects. I have chosen Paisabazaar banking fraud analysis project, and this is my complete project. So let's begin with the project. So in the project is Paisabazaar Banking Fraud Analysis Project, and it is an project type is Exploratory Data Analysis. We have to do data analysis of the project. Contribution is individual. I have done individual contribution, and my name is Rishabh Sinha. I have written a project summary. In short, I have written a project summary about what the financial industry is. After that, why we need this type of analysis in our financial industry. Next, in the next column, I have written about the data set. That means the number of columns I have, number of rows I have, and all the important columns that I have, variables that I have throughout the data set. In the third paragraph, I have written about what do we want to do, what are the steps we will use. So the first step is data import, library importing. After that, we will import the data. After that, we will look at the first view of the data. Then we will start cleaning the data and data wrangling. And then after data wrangling, we will go to the data where data insights. That means KPIs, key performance indicators. We will find all the important KPIs in my that I can take out from my data set. And at last, we have done is with data visualizations. So I have written all the steps here in a paragraph manner so that everyone can understand. And this is my GitHub link. I have also created a GitHub link. And the problem statement are we are given a data set of 81782 banking customers with detailed information about their financial activities, credit history, and personal profiles. How can we effectively analyze this data to detect the flag potential fraudulent behaviors? To analyze the analysis should focus on identifying patterns and anomalies that deviate from the typical customer behaviors, which could indicate fraudulent activities such as credit card fraud, loan exploitation, or unusual financial transactions. We have to use at least 5 different types of charts in the visualization section. So I have defined the business objective. What is the business objective? I have defined in 3 or 4 lines. And after that, the first step was to import libraries. I have imported all the important libraries like NumPy as NP, Pandas and PD, Matplotlib as PyPlot, PLT, Seaborn and SNS, and everything. After that, we have loaded the dataset. We have taken a name of the dataset, PF Paisabazaar underscore DF. I have taken a variable and I have imported the dataset in that variable. We have written pd dot read underscore csv to import to read the CSV file that we have. And here we have taken the first look of the data with a code dot head, Paisabazaar df dot head. We have got the first look of the data. As you can see, all the columns and top 5 rows, because in the head top 5 rows is shown. If we mention 10 or 100, then it will show top 10 or top 100 rows. The next, what we did is we find the shape, Paisabazaar df dot shape. We find the shape of the, we got 1 lakh rows and 28 columns. After that, I look for info also, info of the data set, and I saw that there are 1 lakh rows, no null values in the data set, and the data types of all the columns were almost okay. If only the age column data set was float, that we had to change into int, that I have done in the project. Then we had to calculate the duplicate values, count of duplicate values. So I have taken the length of duplicated values dot length, and we have got 0. That means there are no duplicate values in my data set. After that, I have taken Paisabazaar underscore df is null. We have to find null values, sum of null values in all the columns, and we have got a table. We have got a table with showing that there is no null values in any of the columns. After that, we have also plotted a heat SNS dot heat map Paisabazaar underscore df is null, and we have given the color bar as cool warm. We have the color pattern as cool warm, and we can see we have got a SNS heat map showing the null values, and we have no null values, so not showing anything. What did you know about dataset? I have written everything that I understand that I got from the dataset till now. That means number of rows, number of columns. I have also seen that age is in the float. We have to change it into integer in the data wrangling process, and everything I have written. After that, understanding your variable. So in the understanding of variables, there was two columns. One was columns. That means we have to find all the columns. So the code is Paisabazaar underscore df dot columns, and we have got all the column names that we have in the data set. The second is Paisabazaar df dot describe, include all. That means we have to describe, dot describe gives us the statistics of the data set, like the null values, like unique values, top values, frequency, mean, standard, minimum, 25% deviation, 50% deviation from the mean, 75 deviation from the mean, and the maximum values of all the columns. And you can see we have got all the details of all the columns here in the describe function. And then after that, there was a section to write variable description. So here I have written that we have 28 variables. The most important variables, I have written all the names of the most important variables and what are the target variables. The target variable is credit score. We know we need credit score to calculate many things in this data analysis project. Second is categorized as good, standard, or poor, which serves as a benchmark for analyzing fraud risk and credit worthiness. So credit score is the most important column or variable in our data set. Check unique values for each variable. Then after that, we have checked n unique values. That means number of unique values in all the columns. And you can see we have got the table with number of unique values in every table. Then in the data wrangling process, we did data wrangling. We wrote data wrangling codes. We could wrote codes for changing data type of age from float to integer. We also found duplicate values, number of duplicate values. We also found number of null values, as you can see in the project. We also dropped null values if there are null values. We don't have null values in this project, but if we had null values, then drop it also. And we have printed all the values here, and you can see number of duplicate rows is 0, number of null values before cleaning, after shape of the null value, shape after dropping all the null values after cleaning, and we have got all the with every row, every column. We have seen see we have no null values. Then I also performed an removing outliers step in annual income, because annual income ranges from a certain starting point to a certain peak, but there are some exceptional exceptions where people are drawing much more annual income or much less annual income than the average. So in that case, we have to remove outliers to maintain our integrity of our data set and our data analysis. So I use the IQR method for finding the outliers or for removing the outliers from the annual income method. Q1 Paisabazaar, I have calculated 0.25 percentile, then 0.75 percentile. Then IQR, as we know, is Q3 minus Q1. That means at 0.75 percentile minus 0.25 percentile. And in the while calculating, we calculate that IQR minus, we calculate all the values between IQR 1, Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. The values that we get in between that, we will calculate that only. After that, the Paisabazaar underscore DF income per account. We have also found a new column income per account, and after that, I have also found a new column per account is annual income by number of bank accounts. And we have also found a new column credit score level, that we have calculated by credit score levels. If high, then high, otherwise low. What all manipulations have you done and the insights you have found. So I have written in a short paragraph that what are the insights I have found and what are the manipulations I have done. So basically, I have changed the data type from age to from float to integer. I have also added two new columns, that is credit score levels, income per account. I have also done an outlier removal from annual income section. We have dropped all the null values, if any. And after that, what are the insights I have found? I have written all the insights that I have found and the steps I have done in the data wrangling process. Next, we come to the KPIs, key performance indicators calculation. In the key performance indicator calculation, we calculate the most important insights that we can borrow from the data set. And after that, using these KPIs only, we make the data visualization also. That means charts also. So I have divided this part into four or five categories. The first category is customer demographics. In customer demographics, I have calculated KPIs like average age of customers. Average age of customers was, I have taken the age column and found the mean value of age column, as you can see. So we got the average age of customer as 33.32 years. Then after that, distribution of occupation. I have calculated occupation. I have group by occupation. Group by, I have taken the occupation as a group by, and then I have presented the count of customers in every occupation. So you can see we have got this chart as lawyers is 7,096 customers. Engineers, there are customers who are engineers is 6,864. Likewise, we have got everything. The third KPI that I calculated in my customer demographics was number of customers by income group. Here I have made four income groups: low, lower middle, upper middle, and high. And I have wrote all codes for dividing all these all these bins. I have written all the codes, and then I have appended the annual incomes into this. I have made a new column, income underscore group, and I have divided all the annual incomes by all these values. That means low, less than 25,000 in one, in the low level. In the middle level, I have taken 25,000 to 50,000 if the annual income is for 20,000 to 50,000. And likewise, I have made a chart, and we got low is 33,480 customers. Lower middle, I have got 27,296 customers, and likewise. Second section in which I have made KPIs was financial behavior. I have made a second section called financial behavior. Here I have taken average annual income. Average underscore annual income is equal to Paisabazaar underscore DF. Annual income dot mean. I have taken the mean of the annual income, and we have got annual income as dollar 50,505. Then I have taken average monthly in-hand salary. That means mean of the monthly in-hand salary. I have got average monthly in-hand salary as dollar 4,197.27. Then I have also calculated average debt to income ratio. That means debt to income ratio is calculated by, first we have to find debt to income ratio, that I found by dividing outstanding debt by annual income, and then after that we for getting the average of the debt. First, I calculated debt to income ratio. Then after that, we have to find average debt. So in that, we took the debt to income ratio and dot mean. We did the dot mean so that we get the average value. And after that, I printed. We got average debt to income ratio as 0.06. After that, in this in the financial behavior sections, I also calculated average credit utilization ratio. And the credit utilization ratio was, we have taken the credit utilization ratio. There was a column in our data set called credit utilization ratio. We did the mean of it and we got the average. And average we got as 32.29. Then the average number of bank accounts. We also calculated average number of bank accounts. We had a column number of credit cards. We had a column number of bank accounts. We took the mean function to calculate the average of that bank accounts, and we got the average number of bank accounts at 5.37. Next, we calculated average number of credit cards. So in that, we had a column called number of credit cards. We took the mean of it, dot mean, and we got average number of credit cards as 5.53. Then the third section in which I divided my KPIs was loan and credit performance. In the loan and credit performance, first thing was average number of loans per customer. I calculated average number of loans per customer. Average underscore number of loan is equal to number of loans dot mean. I have taken number of loans. There was a number of loan columns. I took the mean of it, and we got average number of loans per customer was 3.53. The second was average interest rate. Average interest rate. There was column name interest rate. I took the mean of it, and we got average interest rate as 14.53%. Then total EMI as a percentage of income. Then I took a new. Then I also calculated a KPI called total EMI as percentage of income. That means EMI burden ratio. And how did we do this? First, we took the total EMI per month. We made the sum of it. Then we took the annual income, sum of annual income, and then we divided total EMI by total annual income into 100. To get the percentage, we have to multiply by 100, as you can see here. Total EMI by total income into 100, and we got the total EMI as percentage of income. That means EMI burden ratio as 0.21%. The fourth step was average credit history age. Average, what was the credit history age? So there was a column named credit history age in our data set. We took the mean of it. and we got average credit history is as 221.22 years. So the fourth section in which I divided my KPIs was risk and fraud indicators. In the risk and fraud indicators, the first KPI that I found was average number of delayed payments. In the average number of delayed payments, there was a column in our dataset called number of delayed payments. We took the mean of it and we got average number of delayed payments at 13.31%. 13.31. Then the second KPI in this section was delay from due date, average, minimum, maximum. So here we have taken the average due date, delay from due date. We took the number of delayed payments. The column was number of delayed payments common. From that we took mean value of that to get the average. Then we took same for the number of delayed payments column. We took the minimum value of that column, and third we took the maximum value of that column, and then we printed all the three, and we got average delay from due date as 13.31, minimum delay from due date as 0 days, and maximum delay as 25 days. After that, percentage of customers with frequent credit inquiries. So there was a column named number of credit inquiries. We took the mean of it and then multiplied it by 100 to find the percentage of customers with frequent credit inquiries, and we got percentage of customers with frequent credit inquiries at 92.81%. The fourth was percentage of customers with change credit limits. Fourth KPI in this section, change credit limits. So here there was a column in the data set called change credit limits. We took the mean of it and then we multiplied it by 100 to find the percentage. The percentage of customers with change credit limits was 100%. We got 100%. After that, distribution of credit score categories, good, standard, and poor. Distribution of credit score categories were distributed in good, standard, and poor. We have to find the count of categories wise. So here I have took credit score categories as my as group. I group by the credit score categories and found the count of all the customers in those categories. And as you can see, we use the value underscore counts function to group by standard, poor, or good and get the number of customers. And you can see we have got the number of customers. The fifth, the fifth category in which I divided my KPIs was behavioral insights. In the behavioral insights, my first KPI was distribution of payment behaviors. The distribution of payment behaviors. In the distribution of payment behaviors, there was a column named payment behaviors, and there were one, two, three, four, five, six different types of payment behaviors. So I grouped by all the three payment behaviors, all the six payment behaviors, and wrote the function value underscore counts to find the number of customers in every category of the payment behaviors column. And we got this chart as the answer, this table as the answer. The next was percentage of customers who pay minimum amount only. So here we took payment behaviors. The column payment behaviors is equal to low. That means only the lowest value we want, and from that we want the mean of it and into 100 to get the percentage of it. And we got percentage of customers who pay minimum amount only was 0%. 0% customers. Then after that, the fifth step in our project was data visualization. In data visualizations, we have divided the visualizations into four or five different categories. The first category is demographic analysis. In that, we made a number of customers by occupation column. We grouped by occupations. That means by grouping by occupations, we find number of customers in each occupation, and we plotted a bar chart. As you can see, we are here lawyers. There are most number of customers as employers, lawyers, then engineers, then architecture, and likewise reducing. Then after that, the second chart that we used was demographic analysis. In the demographic analysis, the second chart was age distribution column. In the age distribution column, we made a histogram to show the distribution of ages, distribution of customers with different age in the different age group. And you can see the peak is from 20 to 40 to 45. In the middle ages, young to middle ages, there are most number of customers. The third, in the demographic analysis, the third chart that we debate was annual income by occupation. I plotted an annual income by occupation as a box plot. Box plot is used. We made a box plot just to include outliers also, so that we get outliers also. And as you can see, we got this chart, and we can see there are outliers also in every column. In some there are more, in some there are less. The fourth chart. Okay. Next, coming to the next section of the charts. The next section I divided into income and salary insights. In the income and salary insights, the first chart was annual income distribution, and I made a histogram of it. So in this, as you can see in this histogram, I have divided, I have made a histogram for distribution of customers with annual income, whatever their annual income is. And we have got this chart. We can see there was a peak there are many customers who had a salary of low salary, that means less than 25,000 but more than zero. Next was monthly in hand salary. Sorry. Next was monthly in hand in the income and salary insights. Next was monthly in hand salary versus credit score. And in that section good we found a box, we made a box plot for it. Monthly in hand salary versus credit score. I On the x axis we took the credit score as good, standard and poor, and monthly salaries in the y. Here we can see in the good there are less outliers and good performance, good credit score, higher credit scores, and in the poor section we have more outliers also and poor credit score also. In the income and salary insights, the fourth chart was comparing income distribution of good versus poor credit score customers. So here we have made a KDE plot. First we took a KDE plot for good credit score customers. Then we took a KDE plot for bad credit customers, and then we plotted the KDE for both in a single chart. And as you can see, good credit scores are representing by blue shade, and poor credit scores are represented by orange shade. The next KPI was credit and loan analysis. In the credit and loan analysis, we took average number of loans versus credit score. We made a uh, we made a bar chart of average number of loans versus credit score, and we took a bar chart. See, here you can see credit score. We took credit score in the x-axis and number of average number of loans in the y-axis, and we got good, standard, and poor. So you can see that for good credit scorers, they have taken comparatively very less loans than for poor credit scorers. Poor credit scorers are taking more loans. The eighth chart in our project was on the third third category, credit and loan analysis category. The first chart in the credit and loan analysis category was types of loans availed by customer, and it is a starred bar chart. So here first I have splitted all the types of loans, then I have divided all the types of loans by credit score categories. Then after that we have made the stacked bar chart, and you can see loan types are here. We have taken a legend at the side representing all the loan types, and here we have taken credit score good, poor, and standard, and we can see stacked bar chart. We can see here the number of loans. You can see number of loans taken by all the loan types and number of loans of different loan types in a single chart. The next was the credit and loan analysis category. The next was outstanding debt versus annual income with credit score as color. So in this we plotted an scatter plot with annual income at x-axis, outstanding debt at y-axis, and credit score as colors. Credit score, that means good, standard, and poor, at colors. As you can see, the full distribution. The next chart was risk and fraud indicators. In the category of risk and fraud, the fourth category, risk and fraud indicators category. The first chart is number of delayed payments versus credit score. So here we plotted a number of delayed payments versus credit score, and it was a blocks plot. As you can see, we have taken credit score as good, standard, and poor in the x-axis, number of delayed payments in the y-axis, and you can see for good scorers there was number of delayed payments was very less. For poor credit scorers, there was the number of delayed payments was very high. The fourth in the risk and fraud indicators, the second chart was delay from due date distribution. It was a histogram and KDE plot. Both histogram and KDE plot in the single chart we have made. So as you can see, we took number of date delays in the x-axis, number of customers in the y-axis, and we plotted a histogram also and KDE plot also. So you can see number of customers, number of delays. The most number of delays is from 10 days to 30 days. This is the most high peak delay that average people did. The next was in the risk and fraud indicators. The next section was next chart was credit utilization ratio grouped by credit score, and it was a bar chart. So here we use credit utilization ratio as in the x-axis, credit utilization ratio in the x-axis, and credit score in the y-axis. So we can see with good standard and poor, we can see that good scorers are using their credits more, standard are comparatively less, and poor are much and more lesser. Then after that, in 13th chart was in the risk and fraud indicators only, and it was a correlation between numerical features, a heat map. Heat map to represent the numerical, all the correlations between all the numerical features of the data set. And we got the heat map, as you can see here. We got the heat map here. We have also got the color bar here, and we have got all the columns with integer. I have written a code so that we only include integers and floats. We only want numerical values, integer and float columns. There are columns whose data types are integer and float. The next was behavioral patterns. The next category was behavioral patterns. In the behavioral patterns, uh, the first chart was payment behaviors distribution. In the payment behavior distribution, we divided payment behaviors. There were in the payment behavior section, there were six type of different type of payment behaviors. So we divided every payment behavior based on their percentage out of 100 in a pie chart. And you can see in the pie chart we got different types of, you can see 1, 2, 3, 4, 5, all the six. I have also presented a legend also payment behaviors. You can see legends of different colors and their proportions, that means 28.6%, 10.8%, 11.8%, and likewise. Next is payment of minimum amount, yes or no versus credit score, that is a bar chart. It is also under behavioral patterns. So here I have taken number of payment of minimum amount, if yes, if no, or if in minimum, in between. And in the y-axis I have taken number of customers. And we have also taken credit score as three different types of good, standard, and poor. And you can see all the charting that we have got here. The next chart was behavioral patterns. In the behavioral patterns section, the next chart was payment behaviors versus occupation. That was a stacked bar chart. In this we have taken occupations. You can see we have taken occupation in the legend. All the different type of occupation represent different colors we got from set 2. There is a palette color name set 2. We have taken all the payment behaviors, all the different type of payment behaviors in the x-axis, number of customers in the y-axis, and all the different types of occupations I have represented with every payment behaviors here, as you can see in this tag bar. The 17th chart in our project was in the overall credit score analysis category. It was a new category was called credit score category, and in this the first chart was percentage of customers in good, standard, poor categories. So we have categorized, we have made a bar chart. As we have seen earlier also, the credit score category was divided into three groups: good, standard, and poor. So we have represented a pie chart to represent the share of good, poor, and standard, and we have got good share of good as 17.8%, good credit scores, poor credit score customers 29%, and standard credit score customers at 53.2%. And the last chart in this project was in the overall credit score analysis category only, and it was average depth, EMI, utilization across credit score categories, and it was a bar chart. So here in the bar chart you can see we took credit scores, good, standard, poor, and standard as three categories in the x-axis, average value in the y-axis, and financial matrices like outstanding debt, total EMI per month, and credit utilization here it is represented by blue color, orange color, and green color respectively. After that, solution to business objective. What do you suggest the client to achieve business objective? So I have written to address the business objective of reducing fraud analysis, fraud risk, and improving credit portfolio quality. I recommend a data-driven approach using the insights derived from the analysis. First, customers can be segmented based on their credit scores, debt levels, and utilization ratios to identify high risk groups, customers showing consistently high outstanding debt, EMI burden, and credit utilization should be flagged for closer monitoring. The institution should encourage timely payments by offering remainder, flexible payment plans, and financial counseling. At the same time, predictive models can be developed to identify early warning signals of potential fraud or default for by promoting responsible borrowings and proactive engagement. The bank can improve prepayment rates, automated alert, and stricter loans eligibility criteria for high-risk customers will further reduce exposure. Meanwhile, low-risk customers should be rewarded with better credit terms to strengthen loyalty. Over time, these actions will not only reduce fraud but also improve the overall profitability and customer trust of the organization. So, this was the business objective suggest that I would suggest to the client after doing this analysis. And I've also mentioned a full conclusion also at the end about the project, including all the important insights I found, all the important charts I found, and what else the analysis demonstrated to me.